Hi guys, welcome back to the Quants Question of the day, and today we are doing Quants Question of the day 11, and I hope you've been enjoying the series. And I'm sorry I've been irregular with the questions over the last couple of weeks because I've been busy with my revisions of the books, and it's always a hectic time for me whenever I'm revising the books. The LR, DI, and Quants book, all three books are getting revised this year. And that's an additional burden over normally I do quants in the even years and LR and DI in the odd years. But this last year, because quants was not revised because of COVID, I've got all these three books with me, which is one of the reasons why I've been irregular on this. So I'll come back to Quants Question of the day 11, and this is again part of the number system series. And I would think that these will be valuable to you. These videos will be valuable to you once you have done the basic work on the chapter, and after that you want to see good quality questions and learn from them, how to think, etc. So this is the question. The question says a set S is formed by including some of the first 1000 natural numbers. Okay? That means I've got my set S, which I am forming by including some of the first 1000 natural numbers. That's the reaction. One of the things that I always show you in my solving is that you should always react at various points within the problem. It does two things. It makes your solving faster, and second thing it does, आपका solving faster हो जाता है, and second thing it also does is that it makes you understand the problem better because you are reading the problem in smaller chunks. So this is what this is saying, and then it says S contains the maximum number of numbers such that they satisfy the following conditions. So there are a few conditions that need to be satisfied for S. Maximum number of numbers such that they satisfy the following conditions. No number of the set S is prime. Okay, so that's the first condition. So we are building S from this, we are building the subset S from this, and no prime number in the subset S. That's the first indication here. And the second one is when the numbers of the set S are selected two at a time, we always see co-prime numbers. Okay, so we don't want prime numbers. And when you select the numbers of the set S two at a time, the pair is always co-prime. So what is the minimum number of elements? What is the number of elements in the set S? And the set S contains the maximum number of numbers with this condition. So how do you solve this question? I want you to think about this before I give you the solution to this. The logic of co-prime numbers, first let's understand that. What is the logic of co-prime numbers? Co-prime numbers का logic ये है कि I know you know the definition, most of you at least, but maybe some of you are weak at maths, you don't know that, so I'll just explain that to you. Co-prime numbers are two numbers who have an HCF of 1. Two numbers with an HCF of 1. Now when do two numbers have an HCF of 1? When they have got no common factors apart from 1, obviously. That's the obvious thing. But there's another view in mathematics, and you know this we learned in school that every composite number can be written as a product of its primes. That when you write a number like 20 as 2 square into 5, this is the composite or the prime factorization of the composite number 20, and this form of writing the number 20 is called as the standard form of the number. And you will realize that if you start understanding the standard form better, you'll get a lot of grip on the chapter, on the number systems chapter especially, and also it will apply the other chapters also. So स्टैंडर्ड फॉर्म में से बहुत विजन मिलता है हम लोग को इफ़ यू अंडरस्टैंड हाउ टू लुक एट द स्टैंडर्ड फॉर्म, एंड वन ऑफ द स्टैंडर्ड फॉर्म का विजन्स इज when do two numbers become co-prime. So let's say I've got a number 2 square, 3 cube, 5 raised to 1. Let's say I've got this number. I think 27 into 408 into 5. This number is the number 540. Now if I want to find a coprime number to the number 540, I want a number which is coprime to 540. What kind of numbers will be coprime to 540? And this is important for you to understand before you solve this question. So you will realize, or you should realize, that this number, whatever number you take, its prime factors cannot have a 2 or a 3 or a 5. Because the moment you put a 2 raised to 1 here, for example, remember the HCF principle? How do you take HCF from the coprime, from the standard forms of numbers? You take the common prime factors with the lowest available power. So the moment you have 2 raised to 1 and whatever you want to write, you can write that later. The moment you have a 2 raised to 1, the HCF of these two numbers ceases to be 2, to be 1. Hence, what is important for this second number to be coprime to that number 540 that we have taken is that this second number should not have a 2, it should not have a 3, or should not have a 5. So as far as the second number is constructed by prime numbers other than 2, 3, 5, so it can be constructed with 7, it can be constructed with 11 and so on. It's fine. A number like 7 square into 11 raised to 1 will work. It's a coprime to this number. A number like 13 square into 17 cube into 23 raised to 1 will work. It's a coprime to 540, right? So this is the vision that you need to build before you can start solving a question like this. So two conditions. Now when I start trying to count how many numbers will come in, two conditions are that I cannot have a prime number inside the set, and every pair of two numbers has to be coprime with each other. So and all the numbers are below 1000. So when I start thinking about this, if I think of the number 2, for example, I cannot put it in the subset because why? Because it's a prime number. So that first condition eliminates the need for the possibility of putting 2. Same logic say I can't put 3. But what about 4? Can I put 4 in this picture, in this set? The answer is yes. I'm trying to maximize, so I'll need to take every number that's possible, right? So can I take 4? The answer is yes, because it's not coprime. It's not prime. And right now this is blank. So there's nothing inside the set. So it's not violating any condition of not being coprime with anything else. So but the issue now is when I took a 4 inside here, its prime factors are 2 square. Its standard form is 2 square. And the moment I do that, I cannot use 2 in any of the other numbers. So sometime later, if I wanted to take the number 132, I cannot do it because it's not got an HCF of 1 with 4. I want to take a number like 134, I can't do it. I want to take a number like 6, I can't do it. So the moment I have got 4 in my list, all multiples of 2 are gone. I cannot take any other number in which I can put a 2 inside, right? So same logic says, so going forward, if I look through, 2 or 3 तो मैंने reject कर दिया था because they are prime. 4 I could take, 5 I can't take because it's a prime. 6 clashes with 4, it's got a 2 inside it. 7 is a prime. 8 will clash with 4, I cannot use a 2 cube any longer. There. 9 is 3 square. So I can take the number 9 here, which is 3 square, and that's my second number, which will come into this series and into the set. And obviously there's no clash of common prime factors between 2 square and 3 square. And if you realize what we now need to do is, the moment I have got this number, any subsequent number I cannot put a 3 in it. Any subsequent number I cannot put a 3 or a multiple of 3 in it, or any power of 3, which means that I'll have to avoid numbers like 12, 15, 18, 21, 24 and so on. So what is my next number that is possible? 10, no, because it's got a 2. 11, no, prime number. 12 has a 3 in it, 2 also in a 2 in it. 13, prime number. 14 has a 2 in it. 15 has a 3 in it. 16 has a 2 in it, you can't take it. 17 has a 2 in, is a prime number. 18 has a 3 and a 2 in it. 19 prime number. 20 has a 2 in it. 21 has a 3 in it. 22 has a 2 in it. 23 is a prime number. 24 has a 2 in it. 25 is the next number. And now you realize that the pattern is basically squares of prime numbers. That's what you need to take. So the next number you can take is 49, and the next number you can take is not 64. Squares of odd prime numbers, basically, after 2 square. You can't take 64. So 7 square you can take. 8 square you can't take. 8 square, obviously prime numbers का वो आएगा. So even numbers तो आएगा नहीं. 11 square you can take 121. 13 square 169. Now the limit is going to be going to 1000. So you just try to count. You already have 6 numbers in your list. And you're trying to count how many more numbers you can take whose squares are less than 1000. So you know that 17 square is below 1000. The next prime number is 19 square, that's below 1000. You don't need to look at what the numbers will be. So that's now 8 numbers. Then 23 square below 1000. 29 square below 1000. That's 10 numbers. 3, 6, 8, 10. And 31 square, which is the next prime number, below 1000. So you got 11 numbers that you can take, and 31 square is 961, as you know, and that's the last number you can take in this series. So the correct answer to this question is 11. So that was the thought process, and it's a very clean thought process which you need to organize. And this was a good question because it did not, it gave you the conditions, but it did not force you to, it did not give you the exact steps to do. You had to think through, and you have to break questions down when you're doing your quants. You have to break questions down into whether you have a question that is instructing you, hand-holding you to the end of the solution, or a question which leaves you at a point and then asks you to think. Obviously, questions like this that ask you to think inside the question are much more difficult than other questions. So do subscribe to the channel and do spread the word around, and I'll be there. And please let me know what other videos, what other series you want me to bring. I was also lacking short of ideas sometimes. ऐसा भी नहीं था कि मेरे पास टाइम नहीं था कुछ भी करने का, लेकिन कभी कभी होता है ना कि यू आर नॉट इन दैट मूड और इन दैट जोन वेर यू नो कि चलो इट्स प्लग एंड प्ले कि आज ये कर देते हैं. सो डू गिव मी आइडियाज ऑफ व्हाट काइंड ऑफ courses and substructures and problem solving discussions you want me to have, or even strategy, etc., and I would be more than glad to get them for you here. So thank you so much. Bye bye.